So we're going to be practicing solving logarithms. So there's going to be a couple of these that are going to be a little bit different. So let's look at the first one. I can see that I have a log on both sides. I can see that they both have the same base. So we could use the one-to-one property to drop the logs, except we have this 2/3 here sitting out front. So the first thing we have to do is we have to condense it a little bit so that it actually will fit a one-to-one form. So here we get log base b, and then we get 64 to the 2/3 power. So we use the power property to move it to the power. Now, since I have a log on both sides and both these logs are equal, that means what's inside also has to be equal, allowing me to use the one-to-one property and say that x squared, therefore, plus 7 has to be equal to 64 to the 2/3 power. Now, we've got to fix this 64 to the 2/3 power. Now, if you remember, and I'm just going to write this out over here, 64 to the 2/3 power. That's the same thing as 64 to the 1/3 power squared. Because remember, when you take a power to a power, you multiply their powers. So 1/3 times 2 is 2/3. And the reason I wrote it like this and not putting the 2 inside and the 1/3 out is because the 1/3 power is the cubed root. So what is the cube root of 64? Well, that's 4, because 4 times 4 times 4 is 64. Now I have 4 squared, which is 16. So I can rewrite this as x squared plus 7 equals 16. Then you subtract 7 from both sides, and you get x squared equals 9, which means that x equals plus or minus 3. Now, normally we would have to check to see if both positive 3 and negative 3 work, but since this one doesn't have an x in it and this one is squared and that's positive, both of them are going to work because you're not going to end up with a negative inside your logarithm. Okay. Now, the second one's a little different. We've seen one like this before with the exponential, but this time I did it with a different base. So we got one more step to do. So the first thing I'm going to do is, just like we did on the last one, I'm going to separate this 2x as 5 to the x squared minus 5 to the x minus 12 equals 0. And here I'm going to use that algebra 2 idea of factoring by substitution, where I'm going to say u is equal to 5x. So I'm going to use that to rewrite this as u squared minus u minus 12 equals 0. And now we're going to factor. So this is going to factor as u and u, 3, 4. Since this is negative and that's negative, the bigger one has to be negative and that one has to be positive. So my solutions are u equals -3 and u equals 4. But that's not what I want, okay? I don't want it in terms of u, so I got to switch u back to 5 to the x. And 5 to the x, so that I can finish my solutions. Now, the easiest way of doing this is changing it to its log form. So we get log base 5 of -3, so that's x. And this one you get x equals log base 5 of 4. Okay? Now, those are our two solutions, right? Wrong. Remember, you cannot take the log of a negative number. So at the end, we only have one solution to this. And that's our solution. Okay? Now the third one here is like the first one. We're going to use the one-to-one property, but we got a little work to do. Because we can get these both to base 3, but we got some work. Because 3 cubed is 27. Now that we have the same bases, remember power to a power, we have 3 and 3 is our base, we can use that one-to-one property. Since this base is the same as this base, that means that this has to be equal to that. So we get 3 times 2x minus 1 equals 1. And now we're back at algebra 1. Okay, so bring the 3 in. So 3 times 2 is 6x minus 3 equals 1. Add 3 to both sides. So we get 6x equals 4. Divide by 6, divide by 6, which means that x equals 2/3. And that is my answer. Now, next one. As soon as I see I have logarithms only on one side, I know that I'm going to have to condense them and change it to its exponential form. If I have a log on both sides, then I know I'm going to try to use the one-to-one property and condense them and drop the logs. But since I don't have logs on both sides, the first thing I'm going to do is use the product property and condense these by using multiplication. So that's my first step. So I put them together using multiplication. And now, since I have just a log on one side, I can use the exponential form. So we get 9 to the first power equals x minus 5 times x plus 3. And again, now I'm back to algebra 1. So I'd use that one log property to put them together, change it to its exponential, and we're back to algebra 1 solving. Now I am going to have to FOIL this out. So we get 9 equals x squared minus 2x minus 15, like that. And then subtract 9 from both sides. So we get 0 equals x squared minus 2x minus 24. And then we're going to factor. So x, the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. So which one has a difference of 2? That's my 4 and 6. So I put 4, 6. Bigger number is negative. The other one's positive. So my solutions are x equals negative 4 and x equals 6. But again, we got to go back and check our original. If I plug in negative 4, I get negative 4 minus 5, and that's going to be a negative number. And the same thing for this one. I get negative 4 plus 3, which is going to be a negative number. If I plug in positive 6, this will be positive, and this will be positive. So x equals negative 4 is not a solution. My only solution is x equals 6. And then our last one, which is basically like the one that we just used, okay? But we got to do it to both of them. But we're going to get the same bases, but we got to rewrite. So you'll agree with me that 36 is 6 squared. So this is 6 squared to the 2x. And again, here, that's what's going to clue us in on this 216, because 216 is actually 6 cubed. So that's what we do first. And then again, this means this is 6 to the 3, and this is x minus 2 equals 6 to the 4x, because 2 times 2x. Since again, we're using this one-to-one property that these two are the same, that means that these two have to be the same. So that's how I'm going to find my solutions. I'm going to write 3 times x minus 2 equals 4x. And again, back to algebra 1. So 3x minus 6, 3x negative 6 equals 4x. Subtract 3x from both sides, and you get negative 6 equals x. And since it's exponential, we don't actually have to check that solution. Only have to do it with logarithms.